Hello and welcome. This is Bijan Hushiar. We want to create a switch network with redundancy and see how STP is going to prevent loops from occurring. And the switches that I have in here are 2960 Cisco switches. Their priorities are at default and they all have the same priority. No VLAN is created, only VLAN 1, which is the default VLAN. All the ports are in VLAN 1. Therefore, the criteria for electing the root bridge is going to be the lowest MAC address of a switch. First, let's examine to see if STP is present. We go to the privilege mode and perform a show command. Show spanning tree, spanning dash tree. Enter. No spanning tree instance exists. We could abbreviate that command to show span. Right? Very well. We want to see if there is any other VLAN except VLAN 1. Show VLAN. Only VLAN 1 by default. The default VLAN is there and all the ports of the switch are in that VLAN. We want to obtain the MAC address of this switch. We perform show version. The base MAC address of the switch is going to be displayed, which I have already written it down on the switch 1. I have done the same thing for switch 2 and switch 3, and there are no other VLANs except VLAN 1, and the base MAC addresses I have obtained and written underneath the switch name. Now I'm going to connect these switches using crossover. FA01 of switch 1 to FA01 of switch 2, FA02 of switch 2 to FA02 of switch 3, and then switch 1 and 3 are going to connect using FA03. Notice that you don't see the link lights. It's because I have turned the link lights off. Based the information that I have obtained from the switches, switch 1 with the lowest base MAC address will become the root bridge, and switch 2 and switch 3 are going to become non-root bridges. And the port labels I'm going to put over there so we can see them. Okay. So, based on the information that I have, the MAC addresses, switch 1 is the root bridge, and switch 2 and switch 3 are non-root bridges. All the ports of switch 1 are going to be in designated mode. Because it is the root bridge. Port FA01 of switch 2 will become the root port because this link out of FA01 of switch 2 towards switch 1 is the lowest cost path from switch 2 to switch 1. So FA01 is a root. FA03 of switch 3 is also a root port because that is the lowest cost path from switch 3 to the root bridge. Then switch 2 and switch 3 will compete to see if which one of these two FA02s are going to stay open, which one of them is going to be disabled in alternating mode by STP. They compete, and switch 3 is going to lose the competition because its base MAC address is higher than base MAC address of switch 2. Therefore, FA02 of the switch 2 become designated, and FA02 of switch 3 will become alternate, disabled. And by disabling that one port, the loop is going to break and no loop is going to occur. Let me go ahead and turn the lights on for the links to see if our assumption is correct. Disabled. Let's examine the with the command to find out which one is the root bridge. I'm going to go to the switch 1 and perform the same command, show a span or show a spanning -3. The output says that the root bridge has this priority and that MAC address. The priority is the default priority. The root bridge MAC address is the same as the base MAC address of the switch 1 that we are performing show span on. Therefore, switch 1 is the root bridge. Another indication is that both FA01 and 03 of the switch 1 are in designated forwarding mode. So our assumption that switch 1 would be elected as the root bridge is correct. Let's examine switch 2. If you go to switch 2 command line interface and go to the privilege mode and perform show span, you'll notice that it gives us the priority of the root bridge, which is the same as priority of switch 2. It gives us the base MAC address of switch root switch, which is the same as the base MAC address of switch 1, and gives us a different base MAC address for switch 2, which is a higher value than base MAC address of switch 1. This is a non-root bridge. If you examine the ports, the status of the ports are that FA02 is designated, FA01 is a root port. So our assumption was correct on that one too. Let's see if our assumption was correct on the last switch. We'll go to the privilege mode, show span. It gives the priority of the root bridge and priority of switch 3, they are the same. It gives us the MAC address of the root bridge, which is the same as MAC address of switch 1. It gives us a higher MAC address than the base MAC address of switch 1, which is the MAC address of switch 3. Therefore, switch 3 is a non-root bridge. Another indication is that the status of the ports, FA03 of it is a root port, and FA02 is alternate blocked for the time being to prevent looping to occur. I think I also showed you the command show version to obtain the base MAC address of the switches as well. Let me double check to see if I haven't. Let me perform that command, show where. Gives you the base MAC address of the switch that you perform that command. Now, this network has fault tolerance. If one of the link breaks, there is always a path from one switch to the other. Let's go ahead and purposely close this link and see what happens. If we do that, after a minute or so, STP is going to recalculate and open up that port, but it takes about 1 minute for that to occur. So let's wait. I'm not going to stop the video so you can see it, but I'm preparing myself to reconnect this link after this light comes up and become green. FA02 of switch 3 is changing the status from disabled or alternate to forwarding, and that process takes about 1 minute or so. Here you go. The link is back up. So the network has fault tolerance, has redundancy, can withstand one link failure. Let me put the original link back. STP again is going to change FA02 of switch 3 to alternate and put FA01 of switch 2 and switch 1 in forwarding mode. Again, it takes a while, about 1 minute. We have to be patient a little bit with that to see this amber link lights to change to green. Here you go. Now, so this is the root bridge and these are non-root bridge. I'm going to force switch 3 to become a root bridge. I'm going to go to global configuration and type this command, spanning 3 or short span, then the VLAN ID that we are working with, which is VLAN 1. We don't have any other VLAN. And I'm going to force it to become root primary. Press enter. If I close this one, you'll notice that STP is recalculating. Now it's going to make this one, although its MAC address is higher than everybody else, but it will become root because I manually force that on the system. Again, it will take a while for the links to change status. FA02 of switch 2 will come up and become green, and right now switch 3 is the root. We can verify that by typing show command. Since I'm not in the privilege mode, I put a do in front of it, show span. Notice FA02 and FA03 are in designated mode. The priority of the root bridge, which is switch 3, was reduced by the command that I typed, and the MAC address of the root bridge and the MAC address of the switch that we are performing this command on are the same. So we force this one to be a root bridge. Now I want to force SW2 to be a root bridge and showing you another command. I go to global configuration mode, Alt-T, and perform spanning tree or short span, VLAN ID that we are working with, priority. Set the priority of it lower than priority of switch 3. I'll set it at 0. Now, switch 2 will become the root. Notice the link lights changed. This one is going to turn green within a minute or so, making switch 2, because we made switch 2 the root bridge by taking its priority to the lowest possible value, 0. Here you go. We can verify that by performing a show command, span, or show spanning 3 in the privilege mode. You'll notice that priority of it was set to 1 because 0 plus VLAN ID that we have. VLAN ID that we have is 1. 0 plus 1, the priority become 1. So system ID is the VLAN ID. Priority is normally the priority value plus the VLAN ID that you have. And the MAC address of the root bridge is the same as MAC address of the SW2 that we are performing this command on. And another indication is that the ports of SW2 are all in forwarding designated mode. Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.